For example 39, you've got the system of equations 2x plus p minus 1y equals 1 and px plus 3y equals 2. We want to find the values of p such that this system has a unique solution. So we're going to solve this in the usual way at the beginning for simultaneous equations. If I multiply this equation by p and I multiply this equation by 2, then I'll end up with 2px and 2px, and I can eliminate those. So if I do that, I'm going to have 2px plus p into p minus 1y equals p. And I'm going to have 2px plus 6y equals 4. If I then subtract this one from this one, 2px cancels. I'm going to have p into p minus 1y minus 6y. And then I'm going to have p minus 4. If I then factorise y out of this, I'm going to have y into p minus 1. So that's the first term, y times p minus 1. And then minus 6. So that's minus 6y there. Equals p minus 4. Multiplying this out, I get y into p squared minus p minus 6 equals p minus 4. Now this bit in the bracket cannot be 0. If this bit in the bracket was 0, then p would need to be 4, but we can see that p equaling 4 would not make this bracket 0, so you'd have 0 on this side and not on this side. The other way of thinking about it is like with our last example. If we turn y into p minus 4 over p squared minus p minus 6, this cannot be 0 because y would not exist. So, if we find the values of p that would make this 0, we know that those can't be the values of p that give the system a unique solution. So we're going to solve this being equal to 0. So p squared minus p minus 6 equal to 0 is going to be p minus 3, p plus 2. So for this system of equations, p cannot equal 3 because that would make this 0, and p cannot equal negative 2 because that would make this 0. And if this is 0, so if this is 0, then this is 0. And if this is 0, then we end up with the denominator of y being 0, which means it can't exist. And we're after unique solutions. So p cannot equal 3 and p cannot equal 2. Other than that, p can equal anything. For part B, we need to find the unique solution in terms of p. So these were our original two equations, and we got down to y equals p minus 4 over p squared minus p minus 6. We can substitute this into this one. It's easier to substitute it into this one than into this one. So I'm going to substitute this into here. So I will have px, that stays the same, plus 3. This is y. So p minus 4 all over p squared minus p minus 6 equals 2. And this is the equation that I then want to start solving to find x, because I've only got x in here now. I already know what y is. So once I've found x in terms of p, that is the solution. So this was the equation that we just got down to. So now I just want to solve this to make x the subject. So I will have px equal to 2 minus 3 p minus 4 over p squared minus p minus 6. And I'm going to put that over a common denominator. I realise this is dreadful, but we'll see what happens. So common denominator, so I need to multiply the 2 by p squared minus p minus 6. And that's still px there. I'm going to multiply this top line out and then simplify. Actually, that's not so bad in the end. So then, if I want to make this just x, divide both sides by p. This numerator has a factor of p. That is actually p into 2p minus 5. So if I divide both sides by p, this one goes and this one goes. So I end up with x equal to 2p minus 5 over p squared minus p minus 6. So that is our solution for x. Combining that with the solution for y that we found in part A means that we have now solved the system of equations. And our solution is that xy equals 2p minus 5 over p squared minus p minus 6, p minus 4 over p squared minus p minus 6, where p does not equal -2 or 3.